let's talk about independent versus dependent events. Let me give you a scenario. Let's say that I'm willing to pay you $10 if you can flip a normal two-sided coin and get heads 2 times in a row. Is that going to be considered an independent or a dependent event? The first thing we need to decide is, what is an independent event? 2 events are independent if the occurrence of one event does not affect the likelihood of the other event occurring. An example of this would be our 2 coins. So when I flip heads, that does not automatically affect my second flip. A lot of times when you see independent events, you're going to see keywords that are specific to this kind of scenario. You might see a problem that says something like with replacement. Think of this as you're drawing cards and you draw a card and then you put it back. Those would be independent events. I could draw an ace, put the card back, and then draw a red card. The other thing you should know about independent events is that the sample space is not going to change. It's going to stay the same. Here's what I mean by that. If we're thinking about flipping a coin, right? When I flip a coin, I have 2 options. I can either flip heads or tails. For my second event that is independent, notice that I still have the option of heads or tails. Back to my card scenario. If I have 52 cards in my deck and I draw an ace, my sample space is 52 cards, right? When I put the card back, my sample space is still 52 cards. It doesn't change, it doesn't lessen any. When I think about how I'm going to calculate this mathematically, I can think about this as if I have 2 events. So again, let's go back to, I want the probability of flipping heads and then heads again. Notice that I have 2 different events here, and these are independent events. So I know that this is going to be where my probability of flipping a head goes, and I know that since there's 2 sides on every coin and 1 side that's heads, my probability is going to be 1/2. Then I am going to multiply this by my second event, which is also the probability of flipping heads. Probability of flipping heads again is 1/2, and we know this is 1/4. So the probability of flipping heads and then heads again would be 1/4. I can also think of this in terms of my sample space. So again, I could get heads and heads. I could flip heads the first time, then tails. I could flip tails the first time, then heads the second time, or tails and tails. Notice that I have 1, 2, 3, 4 outcomes, but I only have 1 that I'm wanting in this case, which is the probability of heads and then heads. This is how we would do our math for 2 independent events. Now let's talk about dependent events. You run into this a lot where there's maybe a contest, right? So let's say that I give you tickets, you're entered into a raffle, and I pick one person's ticket out of the raffle, they win a prize, and I take their ticket and throw it away. Now your chances of winning are actually increasing, right? Because I have taken one of these raffle tickets out and thrown it away because they already won a prize. This would be an example of a dependent event. Another example of a dependent event would be if I were drawing a card and then I was keeping that card and putting it in my pocket. Again, now my sample space is changing. I no longer have the same amount of my pool, if you want to think of that I am picking out of. So dependent events are 2 events where one event does affect the likelihood that the other one will occur. For dependent event questions, you might see words or phrases that say without replacement. For this one, the sample space or the number of outcomes is going to change. It is not going to stay the same. Let's look at an example problem where we look at the math behind this one. Let's say I've got these blocks right here. Let's pretend they're in a bag and I reach in and pull one out. And I want to know what's the probability that I'm going to pull out a red block, then a blue block, but I am not going to replace it. So I'm going to say without replacement. So again, I'm thinking of this as I have two different outcomes, but I know that they are dependent on each other. I'm gonna go ahead and write my two spaces for my two outcomes, and I know that I'm gonna need to multiply those together. I first need to figure out my probability for a red. I see that I have 3 reds out of 5 total, so I know that this is going to be 3/5, or 3 out of 5 there. However, I take out this red and now I don't replace it. I put it away. So now what's my probability of a blue? I still have 2 blue. That didn't change. But what has changed is how many blocks I have now in my bag. You can see that now I don't have 5 anymore. I have 4. So I have 2/4, or we could simplify this to 1/2 if I wanted to divide both the top and the bottom by 2. So again, this is going to be my probability of a blue, but this is without replacing it. So now I can just multiply and I get 3/10. So my probability of choosing a red, then a blue without replacements would be 3/10. Let's do one more dependent event scenario that I think can be a little bit tricky if we're not careful. The probability of a red and then a red, and again, this is without replacing it. Okay, so again, I still have 2 events. I'm gonna go ahead and write my little spaces. And I know that first I want a probability of a red, but then I want the probability of a red again, but again, I have done this without replacing that other block. So first, the probability of a red is the same, 3/5, 3 reds out of 5 total. But then I'm going to pick that red and put it to the side. So now, again, I only have 4 blocks, and now you can see I have 2 reds. Again, I can simplify this to 1/2, and I get 3/10. So the probability of a red and then a red without replacement would also be 3/10. What throws people for a loop is they forget that they've taken that red out, and so that now they only have 2 reds still left in their bag. I hope you found this video helpful and that you now have a better idea on independent versus dependent events.